The quadratic formula is really handy to use. If all you do is see it, sometimes it seems like it just fell out of the sky fully formed, but it definitely did not. That's not the way math works. It comes from somewhere. So I want to show you where the quadratic formula comes from. Where it actually comes from is I'm going to take a generic quadratic equation like this one. So I don't have specific numbers in there, just a, b, and c for my coefficients. And I'm going to complete the square. So that's a process that we've seen before. I'm going to complete the square with this generic quadratic equation. Well, the first thing I need to do for that is to subtract c over to the other side. So that's going to look like ax squared plus bx. And if I subtract c on both sides, now I have negative c on the right. Next thing, we're going to start this completing the square process. The thing is, in order to do completing the square, the leading coefficient, the coefficient of the x squared term, has to be 1, and it isn't. So I'm going to factor out a on the left. I can do that just on the left because I'm not changing anything. I'm just changing what it looks like. So I'm going to factor out a. If I factor out a from ax squared, I have x squared left, no problem. If I factor out a from b, what's that going to look like? Well, so I have to think of something that when I multiply it times a, I'm going to get b. And what'll work there is b divided by a, and you can look at that for a minute and make sure you agree that when I multiply a times b divided by a, I'm going to get back b. So when I distribute the a back through here, I'm going to end up with ax squared plus bx like I had when I started. No action on the left. Now we're ready to complete the square. No, I know my left from my right some days. No action on the right. All the action was on the left. So continuing the action on the left, let's complete the square. So I got x squared plus b over a times x, strategic space, and negative c. Well, how do we complete the square? I'm going to take the coefficient of the x term, divide it by 2. Dividing by 2 is the same thing as multiplying by 1/2. You can take a minute and think about that. Make sure you think it's true. And square it. That's how I get what I need to fill in the space there. So let's see, that's b squared. That squared is going to go through the parentheses to everything. 2 squared is 4, and a squared. So there's what I'm going to add, b squared over 4a squared, inside my parentheses. That's a fun number. I have to add the same thing on the right that I added on the left. On the right, well, let's see. I added b squared over 4a squared, but I added it inside parentheses that are being multiplied out here by a. So I didn't really add b squared plus 4a squared. I really added b squared plus 4a squared times a. Put it over 1 if you want. I'm going to simplify that before I add it on the right. I can divide an a out of the top and one of the a's out of the bottom. So that's, I'm adding b squared over just 4a. On the left, I've completing the square, so I can now factor this thing in the parentheses as x plus, and it's going to come from here, what I got after I divided the coefficient of the x by 2 and before I squared it. So that's b over 2a. And it's going to factor as a square. That's the whole point of completing the square. On the right, I would like to add these together, add these two terms together. And the way I can do that is by finding a common denominator. Well, let's see. Common denominator for c, that's c over 1. I'm just going to come over here and do that. B squared over 4a. My common denominator, well, the only denominator that isn't 1 is this 4a. So if I multiply my negative c times 4a, top and bottom, that'll get me my common denominator of 4a. Common denominator is 4a. And on the top I have 4a times negative c and then positive b squared. So I'm going to move the b squared to the front, minus 4 times a times c, which is the same as 4 times a times negative c if I put that negative in the front. And you might start to see elements of the quadratic formula creeping in here that you might recognize. Well, my goal was to solve this equation. I'm going to use square roots. So let's see. Next thing I need to do is get the square root term by itself. So I need to get rid of this a. We'll divide both sides here by a. When I do that, a divided by a is 0. I have my just x plus b over 2a squared. And when I divide by a over here, that's like multiplying by 1 over a. So now I have another a in the denominator. I have b squared minus 4ac and 4 times, now I have 2 factors of a squared. Time to take square roots. When I take a square root on the left, I'll get just what's underneath there. I'm unsquaring, essentially. So I have x plus b over 2a, not squared anymore. When I take a square root on the right, there's nothing I can do on the top because there's that minus in there, so I can't take square roots of b squared and 4ac separate or anything like that. So I'm just going to have the square root of b squared minus 4ac. That was supposed to be an a. And since we introduced the square root in there, I have to consider both the positive and the negative square root. The square root of 4a squared, we can actually do that one. The square root of 4 is 2, and the square root of a squared is just a. Last thing left to do, I'm going to subtract b over 2a on both sides. Conveniently, there's already a common denominator of 2a. So when I do that, now I have x by itself on the left, x equals. When I subtract b over to the other side, now it's negative or has the opposite sign that it did before, plus or minus this square root. And everything is over that common denominator of 2a. And there's the quadratic formula. So the quadratic formula comes from taking a generic quadratic equation, ax squared plus bx plus c equals 0, and completing the square.